So there we go. Now we are on YouTube recording. So good. So yeah, today we are going to be doing templates. So templates is actually another one of those features that you don't have to have, but it's nice to have because it makes your life easier. It does. Like it's something you do. You know, when you're coding and you're doing things like function overloading and function overwriting when you're doing inheritance. Those things allow you to have a function name like foo or print or whatever your function is that is really flexible and can take a variety of parameters, different amount of them, different type of parameters. And that's really cool because the idea of achieving polymorphism meaning multiple forms, is that, you know, if somebody's using your code or your library and what they're trying to do is develop a, you know, like a program, and they want to use your print function per se, they don't want to know all the nitty gritty of how you did your print function and like how there's like 20 different types of print function depending on what they pass and whatnot. They don't care about that. They shouldn't care about that. All they really need to worry about is, okay, this function is called print, which is a easy name to remember, and it's something that is intuitive. And I know that if I pass parameters, this thing will work. And that's it. And the polymorphism comes in that like it can do whatever. It can take the multiple shapes of different types of parameters or different amount of parameters. It can do that all behind the scenes to give you your glorified print function, right? So while you can achieve that with overriding and overloading of a function, and just so you know, we make sure we remember, reminder of casting, is that function overriding is when I have something like void foo, and this is inside of a class A. And so if I go ahead and do inheritance on this, and I have a class B, and forget about the public for now, just imagine this is all public. Same with the inheritance. You know, but if I inherit this, and I go in here and make another function foo, this is overriding the first function, right? So when I call foo on an object that is, and of course, if I make it virtual, then if I have an array of pointers of type A, but they point to type A object, then it will run this foo. But if I have an array of pointers and one of them is, even though they're type A pointers, it points to type B, then it'll know to run this one because it's virtual, right? So we have that polymorphism there. We don't care what's happening as long as the right thing is being called, and it's called foo, right? So this is function overriding, and of course function overloading we learn like the first day of class, or maybe even 135 you learn, which is like, you know, if we have a function bar that takes an integer, we also have a function bar that takes no parameters, maybe a function bar that takes maybe a different type of parameter, or you could have one that takes two integers and so on, right? And so you define all of these, and they each take a different set of parameters, and so that it compiles. So when you call bar, you call it with what you need, and then hopefully behind the scenes, it gets to pick one of them, the one that's the closest to the parameter types, and it does that, right? So this is known as overloading, and that's known as overriding. And we have a question. So the only time a function overrides another, they have to have the same parameters. Overriding, yes. Otherwise, you're technically just overloading. So, yeah. Okay. So yeah, that's kind of what you know, and you can use that. But you still, when you're doing things like overloading, you still have to make a single function for every single type. So like you could have 100 functions in there, and if somebody makes 101 types, your thing doesn't work anymore. And with overwriting, it's cool, but you know, you could have a mixture of both of these. You could still end up with 100 different things in there. The functions that override virtual functions will have to be virtual as well. So apparently you don't need to put the word virtual in the derived class. So you don't need to put virtual there. But you don't have to actually, you don't have to add virtual. As long as you're not doing the weird up and down casting stuff, then you don't, you know, you could override without using virtual as long as you're calling it on the right object. So if you're calling on an object of B, it'll call the foo in B. And if you're calling an object in A, it'll call the foo in A. So the virtual stuff is only to resolve issues when you have pointers and you have performed some sort of upcasting to make that pointer, have a parent pointer point to a child object. You have to do some upcasting to get to that stage. That's when you need virtuals to figure that out. And also so that you can then downcast later on and so on. So hopefully that answers that question as well. But the point is that, the whole idea of both of these features is that you add flexibility, you add polymorphism to your code. Especially with virtuals, it's runtime polymorphism, whereas the other two are compile time polymorphism. Templates are going to be compile time polymorphism, and are going to allow you to simplify a lot of this stuff, especially the overloading part. Primarily that. The virtual stuff can come into play, but really we're trying to simplify the overloading, because for built-in data types, you more than likely don't care and don't want to make a difference in your code when you're passing in a float versus a double. You don't want to mix them. Don't get me wrong. Floats and doubles are totally different in terms of accuracy. But what I'm saying is, if you write a function that works with a double, more than likely that would work okay with a float. But if you want to make a float exclusive version that actually keeps things as floats and doesn't switch them to doubles for the function, you have to copy and paste the code and make an int function and make a float function, right? And you might even be able to do the same function for an int if your function is simple enough that there's there's nothing that needs to have precision. But you still have to write 3 versions of the function, right? So, and as we saw with operator overloading, you can actually create, you can overload the built-in operators like plus, minus, subtraction, and so on, and then create your custom functions that can actually add things together that are of a custom type, right? So you can overload the add operator to operator plus, and then overload that so that you can then add to objects that you've made, like class A object and class B object, and you can define what that means, right? So then if you want to actually make a function to add them together, like a separate function, not just overload, then if you already overloaded that inside, it makes it a lot easier to write that function. So ultimately, what I'm trying to get to is, suppose that I have a function called x. So I'm going to say int, x is weird for a function name, but whatever. It's going to take 2 integers. And the purpose of this function is to add the 2 integers together, okay? Just as a simple case. This function would literally just be, obviously we need to pass in some, int a and int b, pass by value reference, whatever. And then the function is literally just going to be return a plus b, okay? Obviously there could be more code, but just a simple one. If I now want to write this function for floats, and I want to actually not have any coercion happen, which is that implicit casting happen, then I have to literally go in here and copy and paste the same function, and now do this for floats. And then do it for doubles too. So just imagine there's another version here with doubles. And then if let's just say that we have some class that we're going to call num. And this could work as long as you overload this operator, right? So reminder, how do we overload that? Well, we write that plus function, so we have to write our class num. So class num, blah blah blah, and then somewhere in here we have that operator plus, and so on, right? So once you do that and you actually overload this operator to work for this class num, then this piece of code would actually work, right? But we still have to write the 3 functions like this, and so on. With templates, what I'm going to show you is how you can take this stuff here and convert it into one single function. Now we have a question. Do functions that override virtual functions always have to... Wait, I already answered that. Yeah, I did answer that already. So yeah, anyways, basically that's the purpose of today's lecture. We can take things like operator overloading and function overloading and combine that into templates to really achieve, the one function that will do it all, per se. Less writing for us and more flexibility for the user of the code. So there are two types of templates. There are function templates and there are class templates, as you can see by the title here. So we're going to start out with the simple one, which is function. I mean, they're both pretty simple. Well, a bit of an understatement because class templates can get pretty nasty, but at least the basic example of each is pretty simple. So let's start with function templates, which are, as the name implies, self-contained to just dealing with an independent function. So let me just go ahead and give you a sort of example and then talk about it. Okay, that'll be a lot easier. Oh yeah, let me see if the thing finished. Okay, I think it did. It did download the video. Yep, 3 GB file. That sounds like my video. Perfect. Okay, so my lecture is saved. Now I can upload it to YouTube. All right. So function template. You're going to write this word template. Then you're going to write the less than and greater than sign. And you've seen this before when you were doing your casting. If you recall casting, and it's actually the reason why casting works like this is because they are suppress applies templates. But when you say static cast or dynamic cast or interpret cast, and if you are still not sure about these, I did make those special videos last Sunday, right before my training started, that talked about the different types of casting, and they're called, like, I think 2 videos are called like what is casting and what is pure virtuals. So you can check those out if you want to know more about casting. But in general, you know, if you're trying to cast something to an integer, this is the syntax that you do, right? And if you notice, you have these weird symbols, less than and greater than sign, that are part of the function, right? Well, guess what? Those come from the template syntax. So we're finally going to get to talk about what those are and why those were there all this time. Because you probably saw casting in 1.5 too. And unless you did the C type of casting, then this is what you were doing. And back then they were like, well, you know, you'll learn about them someday. Just accept this part of the syntax. But now it's that day. So it's kind of nice. Finally, we reached that point. So you reached that spot in your educational adventure of C++ to know what those are. So yeah. So whenever you're doing casting, that's part of the syntax it's casting. Whenever you're doing templates, that's part of the syntax that you put. If you're going to put the word template, you're going to put less than or greater than sign. And in here you have two options. You can put the word class and then some random value here, identifier. Doesn't really matter what that is. It's just going to be it's actually going to be a template variable, but you can do whatever you want there. It could be the word potato for all you care. You can also use, instead of this, the other syntax that will work is to put the word type name instead of class. Technically speaking, they're not identical in the way they work in C++, but we're not going to get that advanced to like worry about the difference. So just know that either of those will work. Pick one. I recommend you pick a class to always use, but just be aware the other one exists in case you run into somebody else's code and you're like, what the heck is the word type name? Oh, it's just an alternative for class. Just think about it that way for now. And when you ever reach the issue where like they actually make a difference, you'll be good enough at that point to just Google it and be like, oh, that's the difference. Okay, moving on, kind of thing. Okay, but yeah. So when you put that in, that signifies that you are about to write a templated class or a templated function. In our case, however, we are dealing with templated functions. So let me show you what that is going to look like. So for now, let's just kind of throw this somewhere else. So it'll look just like a normal function, actually. In fact, we're going to do our X function here. So I'm going to say, in this case, here, let me just copy and paste it if we need it so we can see it. So here's one of the functions. Obviously, we're trying to make them all together. Oh yeah, by the way, I forgot to change the return type here. I wanted these all to be the same type as the parameter so we don't lose accuracy. So, I mean, I could make them int, and you can still use templates for this and benefit from it. But I think what we're trying to really achieve is the same type. Okay? So, yeah, sorry for that. But anyways, What I want to do is I want to return the type that I'm passed in, whether it's a float, integer, string, because I could have done a string version of this and say that's concatenation or something. But I want to be able to return that. So the template is that placeholder for the type that I'm passing in, whether it's an int, float, double, or whatever. And in this case, the word t is just the identifier for that placeholder. So because I picked t there, and t is the traditional identifier to use because it's T for template, I guess. That's my guess, actually. Maybe there's like some high level reasoning as why they decided to use T. But again, you can use anything. In fact, if you need to use two templates, then you want to use two different letters. So in this case, I'm going to say T because that's my return type. And then I'm going to write the function name. So that's X. And then my parameters, which are the two templates. So TA, TB, or not TB, I guess. And then my return A plus B. So you can see that it's identical to the non-templated version of this function. The only difference is that I'm literally replacing the word float with T. Or if this was the int version, I would literally be replacing the word int with T. That's all there's to it. Like I said, function templates are pretty straightforward. Here's the cool thing about this. When you use this function, you could pass it with any type that you want. And it'll be the equivalent of if you had written by hand that version of the function. There's only one catch though. This function is doing an addition, right? So because you're doing an addition in that function and you're using the built-in addition operator, the plus, then the compiler needs to understand what A plus B is. And if they're integers, it knows. If they're built-in data types, it knows how to work with them. Even strings, because it'll just do concatenation. No problem there. The problem is when they're custom. So if in the case of num, for example, it needs to know how to do num plus num. But we know how to do that. We can just overload, as we said, the addition operator, right? Or any other operator that we decide to use. So that takes care of that. Of course, if there's a class called potato, and we're trying to add two potatoes together, and there is no overload for potato, then you'll get an error. But of course, that's not because of the template. That's because you know the compiler doesn't understand how to add that, and you would get the same error even without a templated function if you've written it, we're just calling it potato parameters. Okay, so that's really all there's to it. So let's kind of again analyze the syntax. You write the word template lowercase. You put your less than or greater than signs, and inside of that, you're going to put your templated variables. Again, we only have one variable here, and we need to put an identifier for it. It follows the same identifier rules as any other usage of identifiers, whether it be variable names, function names, class names, whatever it is. So, lowercase, uppercase, alpha characters. Numerics don't work on the first spot. Any spot after the first one's fine. Underscores you can use, but they're discouraged because they're used for system variables usually. So, yeah. Okay? And again, you put the word class in front of that. And you can also use the word type name. Tiny difference, not to worry about it at this stage of your C++ career. Okay? There's one other catch to using the templated function. And like I said, it is that you need to make sure that all of the code in there will work. So again, if you have a plus, make sure that's overloaded. If all this function did, or let's say that this was a comparison function that returned the biggest number. So you have an if statement and blah, blah, blah. And you have to make sure you overload that comparison operator, right? So that's the only catch. But it's still very, very useful, especially when you're working with built-in data types. And here's the cool part about this. When you're calling this function, so like in main, if I say X and then I pass in like 5 and 6, that's it. You don't need to do any special syntax for that. Will work just fine. Let's say we have our num class. So we have a num A and a num B. And let's say we overloaded the assignment operator in those nums. Let's say num is like some big integer class. You can assign numbers to them. We have to, of course, overload that assignment operator for that to work as well. then I can just do XAB and also be okay. Now, obviously, this is just returning, so I probably want to do something with this. So maybe I want to see out it. And of course, for this one to work, you also need to overload the OS stream operator, right? So stream insertion, stream extraction operators, your C and C outs, so that works too, right? So again, for the custom data types, you got to do a lot of overloading to make this code look clean. But that's the advantage, right? This code looks very clean instead of having to do all these fancy stuff. The other alternative is you have that object-oriented approach. You can also, write your functions that are more intuitive, like, instead of overloading the addition operator, you could just write a function called add, and you could say something like, a dot add b, and that's legit as well. So yeah, but anyways, I'm gonna go ahead and first show you how to do class templates before I go and jump in the computer and start doing examples. But for now, just trust me that that's all that it does, and it works. And in terms of spacing, C++ is white space insensitive, so you could do this all in one line, or you could split it in tons of lines. This is my recommended way of doing it. Put the template stuff in the first line, and then start the function in the second line like this. Okay? So, yeah. This might seem scary, but at least with function templates, it's so nice and simple to do. So I encourage you to use templates in your code all the time. All right. Class templates can be easy, but they can also get really messy. Actually, you know what? Before I show you class templates, let me show you one more example with function templates. Let's just say that you had a function that had two different types that you wanted. So, for example, you were trying to write a function y that took an integer and then took like a float, or maybe it took a double and a integer, or two different types, right? And like that has to make sense in your code, how that's going to work. Because if it doesn't make sense in your code, then the template's not going to do you much help. But if that's something that you're actually trying to achieve, then you can just make this be two templated variables. Like we're going to say t and then r. I don't know. Actually, let's do the one after t. So that would be w. Okay? So in that case, if you're trying to write the templated function of that, then you would say template class t, comma, class w, and then just write your function as usual. This one's a void function, so I'll just write void here, and then y, and then put t. Obviously, we need to give variable names, so let's just say ab. So ta, comma, tb, and then just write the code of whatever this is supposed to do. Okay? This, of course, is a void function, so it's going to, we might want to actually pass this by reference, right? Just because otherwise, like, or maybe it prints something to the screen, who knows? So, but yeah, you can pass templates by reference too, so there you go, there's that. So that's how you, oh wait, I guess this one's not T, sorry, W, since we're trying to use two templates. Just be aware that things get a little harder now, because not for you, but like for the user, because like if you're doing something like this, you have to take into consideration that, you know, if your intention of the code is like, okay, the first one's going to be like an int or a float, or it's going to be an int and a double, but I'm not expecting the user to put in like a string and a float, because that makes no sense. With a template, it's like, you know, your dreams are your limits. You know, nothing can stop you into passing two completely random types in here that just like completely just nonsense stuff in here, and it has to work. Otherwise, you get an error. So, you know, this becomes more of an issue of like, do you really want to give the power to the user to do this, or do you want to code the specific instances that you want? So just be aware of that, okay? That now I can pass literally any two types. So you can also mix and match. So like if you wanted to do one type to be always integer, and then the second one's the one that's a template, you could do that. So, you know, you could do something like this. And let's just do function z. So maybe, maybe this one returns an integer. And then the first parameter is going to be the template. And then the second one's like an integer. And there's some code. At the end of that code, there's of course a return statement so that this works. But yeah, so you could do this. I like that. See, it looks weird. These are weird. There we go. Or without the line, I don't know. I haven't written the C in a while, I guess. I forgot how I used to normally write them. But yeah, so that one's a single template, and you can see it's a mix of some template variables, some non-template variables. So whatever you want. Okay, so that's enough of that. Let's move on to the more interesting stuff, which are class templates. So class templates, again, the most basic example of them are really, really straightforward. So let me just go ahead and again, just start out by putting out an example, and then we can talk about them. So just like function templates, you just write the word template, and then you put type name or class, which I'm just going to use class, put some identifier, close that, and then just, instead of writing a function now, you're going to write a class. Surprise, surprise. So let's just say we want to write a class called A, because we love writing class A in this class, literally. And that's because I'm trying to like subliminal message to you to get an A in the class. So I don't use like class F. So yes, subliminal message. All right. And then you can write your functions just as normal in here. So I could write a function like void foo. You know, I just see outs. Hi. So I could have normal functions in here. I could have virtuals. I could have whatever I want. But the reason I'm using a template is because at some point in here, I would like to have a templated variable. So maybe down here, you know, I have my variable list. Maybe I have an X in here, but I also have a templated variable, so TA. Okay, that's why I'm using a template, because at least somewhere in my code, there's somewhere in here at least one template. Otherwise, like, why write a template if you're not going to have templated variables? So if you're using a template for a class, it's because you want to have one of those variables be templated. Now, because that variable is templated, you may end up writing a couple of templated functions. So for example, there might be a templated X function. Well, we have an X variable. Let's just say an add function. Okay, so you know, you might have or here, let's just let's write two of them. Let's write one void and one T. So let's start with the void one because it's easier. So maybe we have a foo version of our function, so we're overloading the foo one. So maybe in here, foo takes a template. TA, or not to get confused, we'll call this one TB. Or actually, no, it takes nothing. Yeah, because well, that one's overwriting, and then we gotta take something. So here, yeah, let's just take in the parameter a template parameter. Yeah. We'll say TA or TB, and all we're doing is we are assigning it to A. This is like our setter function. Okay, so maybe pick a better name actually. Let's call this set A. Yeah, that's probably a better name for this. And then you know, we take some parameter. We don't have to take it by reference, but if we do, maybe because it's a setter, one good practice to do would be to write the word const, right? In there, and maybe also here. Oh wait, no, not here, because we're actually setting it. But there, yes, at least. Right? Because it's passed by reference, but we don't want to modify it because it's just saying it. So, yeah. So then you just do A gets B. Okay? So that is a setter. So in this case, we're passing whatever this template variable is, we're passing the equivalent type here and we're assigning it. Makes sense, you know? If we have like an integer, we want to pass another integer to assign it. If we have a string, we want to pass another string. If we have a num, we want to pass another num, right? So, okay, seems legit. Let's do a getter. So the getter will be valid returning. So we want to return the type that this template is. And we're going to call this get A. That one has no parameters, but we do want to add const because this is now a read-only function. And this is just going to return A. Okay, so there we go. That is going to be our templated function. Now, this is nice because you can see that even though these are templated functions, we don't have to write the word template in there. So that's kind of cool. But that's only because we're doing these inline functions. Let's go back to foo. Suppose that we wanted to, like I was saying earlier, to overload foo, to have a version of the function foo that has a template in it. So like maybe we have, you know, some parameter t like that. Actually, I don't want to make that be the same. So let's do g. Okay. So in this case, we have parameter g, and something is going to happen in this. So let's just say that we're going to increment it or decrement it. Okay. But the point is that we're not going to write this function in here. So actually, here, let's write it in here first and see what it would look like in here versus outside. Okay. So if we were actually going to define this function in here, what that would look like would be maybe just take g and then plus it, okay, like that. So that would be our code, but we're not going to do that inside of the class declaration here. Instead, let's move it from our header file to our CVP file or whatever and put it there. Okay, so instead, when you finish writing your class, if you want to actually define this function because it's templated, you are going to have to rewrite the word template in here. Class T, and then go in and write your actual function. So void, and here's the trick. So normally, if this was a normal function, you would write something like this. Foo, and then you would write your function parameters. So g. So this is wrong. I'm having a mistake in here, intentional. Okay. And then go ahead and put your body of the function, which we have up here. So let's just bring it down here, like that. Okay. However, there is one thing missing here, and that is because we are using a templated class, we don't just write the class name here next to the scope resolution operator. What we do, and this is where class templates are a little bit weird, is you're going to use your template brackets and then put the template name in there that this class is going to be using. So that would be the T. Okay. So, and then and don't forget, of course, your scope resolution operators. So yes, things get a little bit weirder when you're not doing it inline like this. When you're doing it inline, it looks clean. There's no even the word template in there. It just kind of works. It's nice. But when you're doing it outside, you are going to have to do it like this. Let's do one more example. Maybe one that's value returning. So let's say that we want to take this function here and we're going to make the same function but make it outside. So we're just going to call that one, t get a2, because this is like version 2 of that function, and like that. Okay, we're not going to do the const on that. And then outside, what that would look like would be template class T, and then in this case it will be T because it's value returning, and then get A2, but we got to write the class name, so that's class A with template T, and then return, what is it, A, I think we were doing? Yeah, return A. Okay, so that's what that looks like. Of course, there's a lot more writing than just this. As you can see, this version is nicer. It's just literally 2 lines. Well, 3 lines technically with the curly brace, whereas this one's like 4 lines, but they're actually bigger lines, right? So you gotta think about all this stuff. So I suppose that's kind of like the downside of that. I do have here some syntax, which I'll paste just because it's kind of nice. So here's your little cheat sheet when you're doing templates, right there. So if you're trying to do a function template, it's just template class type, put the return type, put the class name, and then put the type again, and then put the function name, and then put the parameter list, and then the curly braces, okay? So this is what you can do if you're trying to write a function outside the class, okay? That's part of a templated class. So let me write that here. So writing a function, not writing, I think a better term would be defining. So when you're defining a function outside a templated class, as we just did. Okay, so if you're doing that, like what we just did above here, this is your cheat sheet. Okay, so write the word template, put the class T, put your return type, which could be templated type or not, depending on what you're doing, or it could just be any type. Put the class name, put the template less than or greater than symbols, put that template variable in there, which should be the same one that you have up here. So these two should be the same. Put your scope version operator, put the function name, your list of parameters, which may include also a template variable T, and then your curly braces, okay? And then of course, those are coming from your class name, which is that one. So class name, template types, identifier. Okay? So, actually no, sorry, this is a reminder for something else. This is the cheat sheet for the actual declaration of templated class objects. So, instantiation of them. Okay, so this is how you write a templated class. Unlike template functions, when you call them, they just look normal. Like you don't even know they're templated. In fact, a lot of the functions that you call in C++ that are part of libraries that you've been using since 135 are probably templated, but you didn't even know that. You didn't even need to know it. You just call the function and it worked, right? That's the whole magic. With template classes, it's a little bit different. It's more like what you see when you're doing your casting. You actually are seeing the less than and greater than sign because these are templated. The reason why is because when you're actually declaring an object, instantiating an object of a class that is templated, you have to actually specify what the template should resolve to. So in my case, my class A if I'm trying to make an object of that class, so let's make like 3 objects. We're going to make A, B, and C. Or actually, that feels weird, so maybe we'll call them A1, A2, and A3. Okay, so if I'm trying to make 3 objects, when I decide to make the object, the class code is going to run to instantiate that object. I need to decide this at compile time, what that type is going to be. So if I want the template to be an integer, I'll write the word integer there. If I want it to be that num class we were talking about, I can write the word num, or the class name. If I want it to be a string, then I can write a string in there. But the point is that I have to specify the type. So once I do that, what's going to happen internally at compile time is it's going to like literally copy and plug that in everywhere in the code that you see the T. So like it's going to try to literally plug in the word, let's say string, into T everywhere. It's going to check that the code compiles with that version of the class. And if it does, then it's like, okay, thumbs up, you're good to go. If it's, let's say it's running num, and as it runs num, you know, like it's checking the code, and for the function set A here, it tries to do this A equals B, and for some reason it doesn't work with the num. Like it's not overloaded correctly or something's wrong. In that case, it will give you a compilation error related to the template. Or it'll actually just fill it in and give you the types that it actually is resolving to. So that is why you need to define at compile time what the type is, because it needs to be able to have time to check that. Some other languages are more chill about that, Python and whatnot. C++ is very strict with this stuff, with types. So it needs to know. So you got to tell it at compile time what the template is going to resolve. And you're like, well, then if I'm telling it a compile time, couldn't I have just coded it? Well, yeah, but like these 3 lines of code have each different types. So you would have literally had to copy and paste your class into like 3 different versions. And if you ever want to update the class, you better remember that you got to update it in 3 different spots in the code. Otherwise, you're going to run into problems. So templates are still very useful, even though you have to sort of decide what you want it to be at compile time. That's why it's known as compile time polymorphism. And it's still very, very useful. And this is also why the syntax for the casting is kind of like this. Static cast is the class name. What you put in there is the type you're casting to. And then the parameters there is what you're getting from. So it's also not the difference. But anyways, and that's what this cheat sheet's actually for. When you're declaring your templated object, then you put the class name, what you're trying to resolve to your template, and then the identifier of that object. Okay? That is all there's to it. Again, with classes, things can get really nasty because when you do inheritance, composition, and in general, when you have multiple templated variables in the class, it can get really kind of messy, and you can end up with like the word template like 5 times layered on top of each other. For the next half an hour, we'll try playing with that. And it can get kind of tricky to resolve some of the errors you get because you don't do it right. So template functions are always easy, but template classes can get pretty messy and hard when you're doing inheritance and other fancy things because you really have to keep track of the templates. Otherwise, the compiler will complain and yell at you. So if you do run into an issue when you're coding with templates, your best bet is always to just Google the error, and typically you will find some Stack Overflow or documentation telling you what to do. I mean, you can ask us as well, but I'm going to do the same thing you're going to do. I'm literally going to Google the error and tell you what I find, because most of the time the errors are really weird. Can we also use it with that? Well, you know, I don't know because I don't know what like the assignment is going to be. So I really don't know how hardcore they're going to go with the templates. But I highly doubt in the exams, but then again, I'm not making them. But I highly doubt they're going to make you doing templates with inheritance. But I'm just saying, in the real world, you probably will want to use inheritance with templates. So you are going to run into these issues. So just be prepared. But here, let's just jump in and start coding. Specifically, I'll do a function, but you know, I really want to run into some of these issues so that we can try to resolve them and see what they're like. But yeah, okay. So let's start out with a simple class. No, just a simple function. Templated function. So yeah. So we're just gonna do the one we did before. So we'll say TA, MTB, and then just do A plus B. And here we're going to save time, I'm just going to see out it here. That way I don't have to write my main longer. Okay, so this function's job is just to add the 2 things together and then print them to the standard IO. So now I can literally go in and say foo, var, and 3, foo, 4.2 float, and another float. What I cannot do, and I'll comment it out, but I will uncomment it later so we can see that error, is give it different types. So like, let's give it an integer, and then let's give it like a double. Okay? But again, I'm going to leave it a commented out now, because I don't want that error right now. So let's pass in 2 doubles. And finally, let's pass in 2 strings. Or actually, let's do 2 cars. That one will be interesting. All right, so here we go. Strings, cars, doubles, floats, integers. Most of the built-in ones that I can think of. We could also do pointers, but that would be kind of scary. So yeah, okay. So let's run it and kind of look at the output. 3 days later. We got an error with one of them. Okay, let's do terminal. One of them it did not like, which is the, okay. In instantiation of void foo TT, with T being a constant character pointer. Ah, as you can pass by value. Invalid operands of type constant car. So it did not like the two cars that we did. It did not like me passing the two cars. So we'll fix that later. Let's just comment that one out for now. And then run it again. Wait, that was not that one then. Which one is it then? Is it the... Oh, I know what it is. Yeah. Yeah, you're right. Yeah, this is actually pretty cool that it came out. So here's the issue. In C++, normally when you're writing, you know, like a set of characters like this, we think of it as a string. And like that's okay. But because you're hard coding it here, it's actually not hard coding it as a string. It's hard coding it as an array of characters that is constant and you can't ever change it. And so this is kind of yelling at me because when you're passing this to this, you're actually only passing, I believe, the pointer to that array because you're passing an array essentially. And so when you're trying to add this here, you're trying to add two array pointers. So this would be the equivalent if I write the following code. So I'm going to make an array of characters of size 4 that is going to have, like, you know, actually, well, size 2 technically. I believe that would be the case. So that's my array. I got to give it a name, so let's just say V. Okay, and so if I pass this to a function, what I'm passing when I say foo like V, so let's just say I pass it twice. Remember, this is only passing a reference to that array, and so this is a pointer. And so now when I'm trying to concatenate two arrays, it's like you can't concatenate arrays, or you can't add arrays together unless you do some magical stuff, overload or whatever. So that's what it's yelling at me for. So good catch on that. Good catch on that. I forgot about that being a thing. To fix that issue, I can just make two strings. That way I'm telling it, hey, these are strings. These are not arrays. And it'll stop yelling at me, basically. It doesn't actually even matter that they're constant. But that does it for optimization purposes. Even this would cause issues. So, yeah. Nice little review of C++ there. Oh, here, let me comment. Damn it, it ran. I want to run that, though. Let's run it again. Okay. All right. Everything was awesome here except for the part where I should have put a line feed here to make it easier to read. So let's add that line feed and run it one more time. Okay, so let's look at it. So the first one is just a 4 plus 3, which is 7. So what's happening here, it is resolving this to be integers and it is doing integer addition. The second one is floating point addition. So it's resolving this into being 7.5. The next one is doubles technically, and that one is 5.5. And then finally for the cars, this is kind of trippy, but you're seeing here 198 because what's happening is that, you know, the car ASCII table, look at the ASCII table, and I'm going to guess that 99 is the equivalent of the C character. Let's pop up Google here and see it. So ASCII table. So 98 right there. You see that? It's really tiny, but you can trust me that it says 98. Or actually, sorry, 99, not 98, 99 for that. Okay. Here. There we go. Then that way you don't have to trust me. You can see it to believe it. So what's happening is it's actually converting it to an integer, and then it is basically giving me back that. If I wanted to to do that, to convert it back to a character within the function, I would have to do some sort of if statement that checks the type of this. which I know how to do in Python. You just do the type function, or actually use is instance of. In C++, however, I don't know what. I mean, I think I've seen it. I think at some point I Googled it for a class and I forgot it. But let's just Google it. It's instance of in C++. That's kind of what we need. Equivalent of its instance of. Oh, is it really just called the same? Why are templates in? Oh, that's because they're using it. Templates. Is base of. So is that the name of the function? Is base of? Well, is base of sounds more like an inheritance issue. Yeah, so that will help you with inheritance, but not really with other types. So there's probably not an easy way of doing it. Yeah, this is casting, but casting's not really gonna. It's not gonna help it with built-in data types. So I'm not sure. But hey, other languages you could do that. But for this, you're kind of stuck there. So yeah, we'll let it be like that for now. I guess we could do a try except, you know, and then just catch the exception and skip it. That could work too. But no, that won't compile though. Yeah, there's no clean way of doing that within the function. We probably want to do that outside the function. So yeah, but anyways, as we can see, the string thing finally worked. Now let's go ahead and uncomment this line of code where we're passing in what is definitely not the same two types. Already you can see that finally VS Code is useful in underlining something that is not good. In fact, I'm going to just run that in the terminal so that you can see the error better. So remember, it's always as important as learning how to code is learning how to read these errors, because you will run into them. And so let's see this. In function main, line 12, character 15, which that sounds about right. Although the character 15 doesn't sound right. Oh, I guess it's looking at the little parentheses as the location. No matching function call. So it's not finding a function that will work for this. Foo and double. Could I overload and add that special instance somewhere in here? Sure, I could do that, but I haven't. Furthermore, why it's complaining is saying that, okay, well, I can't find it, but here's some possible candidates that could be it. We have a function that's templated, but as you can see, it only has one template type, and the two parameters match the same type. And it's telling me that when I tried to match it to that candidate, the substitution or deduction failed. Deduce conflicting type for parameter t int and double. So it's saying, hey, I have an int and a double, and I'm trying to deduce it to both be of the same type, so that is not working out. It failed. So this is actually a really good error that's telling you exactly what is wrong in your code. You just have to actually read it carefully to understand that's what it's saying. And so, of course, the solution here is to either make a brand new template function that can take different types, or to make a specific function that can take those two specific types. So I'm just going to go with the latter because it's more template stuff, or actually not the latter, but the first one I mentioned, because you can see that example. So we're going to class W. And now we should be okay, I think, to go. We'll see. And there we go. We get 6.2. I think this one's the one from that one. 5.5. Yeah, that one's from that one. Okay? Of course, just because it compiled and ran doesn't mean this is the best thing you want to do now, because, of course, now you can run into a situation where somebody could actually pass, like, you know, something like a integer and a string. And of course, that's not valid, but you are going to get the same error. You're going to get an error that says like, actually, no, you're going to get a different error. You're going to get an error that the concatenation failed. Or you get no error. Why do you get no error? That's scary. Let's see what happened here. Ooh, that's scary. Why did that? What is? Ooh, okay. As far as I remember, you can't add a string and an integer together. Let's run the debugger and see what dark magic is happening here. Actually, let's run it with that breakpoint. Okay, so all right, that runs that line of code. Okay, so we're gonna go here. We got the two variables we're watching. Let's see what goes on. So it's going into the function that we added. Yes, good. So it is, maybe it's adding the pointer itself, or just the, oh, so it's adding the age. I think that's what it did. I think it added the age. That's weird. So it added to the age the value of 4. FGH. That's weird. I don't know what's happening there. So, yeah. I mean, like, as far as I remember, if we do something like 4 plus A, oh, can't type end line. That's giving us a 7. No, that's not giving us anything. I don't know what that's doing, to be honest with you. That's weird. I feel like I remember that being actually a compilation error, but now it's just like, it's giving us a T. Let's see if I can think what's happening there. So, well, okay, this could just be a car addition, but if we have a string, which we know, oh, you know, I think I know, I think I might know what's happening here. Yeah, I know what's happening here. Oh, this is fancy. So actually, what is happening, again, we're being trolled by the compilers, like constant character array again, okay? So I need to draw pictures to explain what happened there. Now I'm gonna sound smart because I actually figured this out instead of like, you couldn't figure out. So the function call is foo4, high, okay? So this is actually pointer arithmetics, what's happening here. So, which is scary stuff. The high is, again, because we hard-coded it, a constant array of characters. So somewhere in main memory, we have an array of H and I, okay? And so we have this array here. And so when we're saying 4 plus the parameter, which this is B, you know, we're saying, and this is A, so we're saying 4 plus B, what we're saying is, let's say that this is stored at address 400. We are saying take address 400 and add 4 to it, okay? But this 4 addition is not just like your old, you know, run-of-the-mill, like, you know, just add 4 to the number. This is pointer arithmetics. Pointer arithmetics, what it does is it looks at what the type of this pointer is. So in this case, this type is a type car. And it's actually going to add that amount of space to it. So for example, an integer, we know that an integer takes 4 bytes, right? So when I say, if I have an integer pointer called x, and I'm adding 4 to it, it's actually going to add 4 increments of integer type. So it's going to be 16. So if my hex address is 100, in hex, that 16 is just going to be 0x110, I think, right? Yeah, because that's going to go 101, 102, all the way to 109, and then 10A, and then all the way to 10F. And then finally, from there, it's going to go to 110. So yes, so that is going to jump there, okay? That's a plus 16 addition to that, which of course in hex would be just plus F, I believe. No, sorry, not plus F, plus 10. Okay? So it's pointer arithmetics and it's adding that. Now the only question I'm not sure about is, when you're doing the pointer arithmetics, if it's doing an increment in sizes of 2 or 4 because of the way the cars work. My guess is it's doing it in increments of 2, but we can actually see that very easily by printing out the address of that. So you know, let's just say so we have our high, and what we're going to try to do is, I hope it lets me do both at once. Actually, here, it'll be easier if we just write a function. So let's just write a temporary function, because it's actually pretty interesting stuff, where we're just going to pass in the two types. So integer a and the const car pointer b. Okay. And so now we're going to do the function call up here, and we're just going to call this f so that we can see it. And then in here, the first thing I want to do is print out the address of b. So we're going to do that by using the address of operator, right? Okay, and now we're going to do the addition. So a plus b, and we're going to see out that, but I'm also going to see out what the address of that addition is. So addition address. Also, let me do an end line here, end line here, and that address addition is going to be a plus b, but we are just going to call the address of operator again, okay? And that will tell us what this pointer arithmetic is doing properly. Okay, we got an error. Which one did it not like? L value required for unary b operand b, a plus b. Okay, don't worry about that one. Ignore it. Let's just run it like this for now. It might be already returning the address, that's why. Okay, so as we can see here, the address of B is this location, and then it's returning that. This is H. So what is H in integer? Let me print that out first. I want to see what this is actually equal to. And then static cast character ch. Okay, and then I want to print out what this forward slash is, because I might be doing something else here. Let's see. Oh, not that one, the other one. Oh no, it's frozen. Oh no, the whole VM is frozen. That's so tragic. We won't be able to see the conclusion to this now. Let's give it a second and see if it survives. I can move that. All right, hold on. I know how. I can just run another VM. Just let me see if I can fix it. Okay, we are going to just run. Do I have? Ooh, I don't want to use that. Okay, we'll try this. Hopefully this has C++ installed in it. Ooh, that's a big screen. Okay, we are now in Kali. Hacker mode. Ooh, whatever. Alright, let's see if G++ is installed in this. I hope so. Yeah, okay, it's installed. We probably don't have VS Code in here though. Hey, in the digital forensics, I learned how to do RAM dumps. That was fun. Here, let's just make a file. Yes, VS Code. Okay, so now let's make sure that this is sort of lined up. Okay, that'll kind of work. Let me just triple check that this is gonna work. Oh, okay. I haven't written that include in so long that I just literally forgot that. Very sad. Okay. Okay. It worked, so we can keep going. I don't have it linked to the debugger, and it's apparently downloading the C++ language components, which it just did maybe. Nope, it failed. I don't think I have the Kali VM connected to the internet, so it's fine. It's whatever. What's your top words per minute? I have no clue, but it's definitely not this when you're typing sideways. I'm literally typing sideways. So yeah. Okay. So can I replicate what I had? Is the real question. Is this one still frozen? That one's still frozen. I don't even want to. I'll try. We only got a few minutes either way, so we can definitely fix it later. But we had, I think, a 4 and the word hi in here. So we had void f, and then I assume this is an integer. And then except this is a const car pointer. But this is the only one. Let's just templates because then we can guarantee. No, that's not it. Just to test that. And then we'll pick up with templates next time too. I have dedicated all week for templates anyways. We'll just do a bunch of class templates on Wednesday. But okay, so let's just start out with this and see if that will get us somewhere. Okay. And you can see this, right? Okay. All right, so we get a T out of that. I thought we got a different letter before. Okay. So maybe this is just doing. No, I don't know. We'll see. Okay. So I wanted to see out the address of this, so I want to cast this to an integer so that I can see the address of the first element of that, which is the H. Or sorry, not the address, the ASCII of that. And I also want to see the ASCII, I guess, in this case of T, since it's giving me T back. And I want to make sure I have line feeds. (104, 84, and T). 104 and 84. So that is a difference of basically 20. That's strange. If it's doing pointer arithmetics, then it would be accessing here. I know how we can check if it's doing pointer arithmetics. Let's just pass in a bunch of those. And if it's doing pointer arithmetics, it would print out an I. Aha, so it is printing the I's. Okay. So where's that T coming from? That T must be coming from somewhere else in memory, like garbage data. That's why we were getting a backslash. So this is doing pointer arithmetics then. Just so we can see the pointer arithmetics is easier, let me number the I's. Like that. And then run it again. Okay, cool. So there, okay. So this is what it was doing what I was telling you. So let me just explain that and then we can call it. So, okay. So as I said, here, what is happening is we're starting out with the address of whatever this address is. In fact, what address are we getting here? We are getting address here. Let's run it one more time just so we can see the address of that. So address of B is going to be address of B. Okay? All right. So the address of B is address 7FFFED05CDB. CDB0. Okay? So if I copy at least part of that, here, then we can see, I know you can't see the address right there, but, well, yeah, you can, Let's just copy the last 4 digits, so CDB0, okay? So when we're doing the pointer arithmetics plus 4, and we're seeing that the initial string is like H, I, or sorry, not I, but I, just one I, and then it goes from 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, all the way to 0. 9, 0. Okay, and we can see that it's only printing out from here to the end. Okay, so as you can see, the plus 4 there is equivalent to shifting from index 0, 1, 2, 3, 4, all the way to index 3. Okay, so this is like index 1, index 2, index 3, index 4. You see that? So that's your pointer arithmetics. So it's shifting it by however much space the H is. Now, if you want to see what that is, that's what I was trying to see out, but it wasn't letting me. So I can probably get it by just C outing. So address shifted is going to be, so I was trying to do A plus B and then just take that as an address, but I think it'll let me do it if I put a 0 there and then put an address off. I think that will get rid of that error that we were getting earlier. Oh, well, semicolon. At least didn't give it, so this might work. There we go. Okay. Another address off, maybe? Maybe it's complete. Maybe what I need to do is that. I can't get the address of that. That's annoying. That's going to give me a 3. Okay, so now I just want to get the address of this location. That's giving me that. Okay. Let's cast it. Or no, casting won't do much. Okay, I have to remember how to get the address of that. But the point is that it's just shifting it. So what is happening is it's shifting it by 4. So it's going from the H of high, and it's going all the. Oh, you couldn't see that a little bit. But let me push that a little bit to the side here. There we go. So what is happening is the plus 4 is shifting it to the 4th index of the, well, technically the 5th one, but it's the 4th after the first one, so the 5th index of the array. Now, the reason why it's printing from there to the end is because it's a constant car array, so like it'll just print all the way to the end until it sees a null. So it's just gonna like blah, you know, print out the rest of the array. So that's why you see the rest being printed like that. In the case where you see like the address shifted stuff, but yeah, that's why we were getting what we were getting basically. Okay, pointer arithmetics. So believe it or not, because it was shifting the address reference that we're passing it in. So it took that address that is in this case ending in 680 or sorry 880. It took that address, it added 4 to it, but it's not just a simple 4. It's doing the 4 of the size of the array. So in this case, it's 4 of the size of the car, which I don't know if it's 1 or 4, how it's doing it internally. Doesn't matter. But the point is that it's adding 4 increments of those, gets a new address, which is the equivalent to where the 3 is, and it prints from there to the end. Now, before with just a high, what we were getting is an out of bounds issue. We were printing out some garbage value. In this case, we had a T. In the other VM, we had a slash. So that's just garbage data that happened to be there. And it'll print that until it gets to the end of that. So that's what we had that. So I didn't want to leave you with a question hanging. Now the only question is, how can I print the address of the 3? But it's not cooperating with me. So maybe if I do it like simple. Okay. Oh, well, I guess, sorry, 4, not 3. Sorry. And then if I do the address of operator, what could I do to like make it give me that address? I would assume that giving it another dereferencing would be okay, but it complains. I don't know how to get the address, but how about you guys figure it out and then let me know next time. I'm trying to get the address of that element. So, yeah, but very cool indeed. Okay, so sorry that we can't go back to the other one to see it. It's still stuck, so I'm gonna have to restart it. Hopefully it saved the code if it for the day, and then I can upload that on Wednesday. But yeah, as you can see, things can be unexpected when you're using templates if you don't handle all the cases. I was expecting that to not compile, and like if I was giving that to a user, I would be like, it's okay because it won't compile, but it does, and it gives us garbage. So the moral of the story is templates allow you so much flexibility. You have to be careful not to give it so much flexibility that you have edge cases that you don't account for, as we did in this case. So it's a good, good happy ending to our story. So like I said, on Wednesday, I am just going to spend the entire day going over all of a bunch of class templates, and we'll probably run into more weird issues like this. So, yep. Until then, wishing you a good rest of your evening, and I will catch you around on Wednesday. All right. See you all later. Bye. I'll fix my VM by then.